Just to avoid confusion, I wanted to mention what this video is about. It is about people breaking their charging ports on Bluetooth speakers and my sort of bag of tricks around that. And traditionally, I've used kind of like an umbilical cable back to a USB-A port. But in this case, what I did was this particular unit had a sort of like a power bank out port, and I repurposed that as an in port. So that's what this video is about. So we have a relatively expensive Bluetooth speaker which has become inoperative due to its micro USB port breaking apart, micro USB port being broken. And the thing about these things is they all have these little ports, and if you're not very careful, they eventually break and then you can't charge them anymore. Now this port over here, this is if you want to use this as a power bank to charge a phone or something. You put your phone in there, and you see there's either two things I can do. Is I can take that out and put sort of an umbilical cable to this sort of connector goes into a charger, or what I could do is I could rewire it so this is actually an input port, and it goes to where that used to go. So the thing about the cable, if I put the umbilical cable kind of thing into here like I've done with other phones, what's good about that is it's very electrically similar to the original condition, which is slightly different for me to rearrange these signals there. The internal wiring has some issues, but not serious issues. On the other hand, people don't like necessarily a Bluetooth speaker with a cable on it. What is good about that, however, is that it has the correct sort of connector, and in this case this is kind of a weird connector. You can do it. There's different solutions for a cable like that. I have one myself. So this here is a USB A to A cable. You don't see these very often. You can buy them. What they're usually used for is devices like hard drives, and what it is, in this case it works because I can put it into that the output if I make it an input, and I can also put it into a charger. What you can also do is if you have like a USB-C charger and a USB-C to this cable, it's actually going backwards from like the way you'd use it for a phone to your computer, but it would technically work. So watching some other people who actually replaced this faulty port, which is a common problem, it became clear that it wasn't that hard to get to the part where I would need to be at to do it, which involved just the I/O PCB. I was looking for it, but I didn't really see a packing bit, and maybe that packing bit would have been important to limit vibration. So hopefully it's just still there and the board is on it, but I kind of doubt that. So I managed to download the service manual of maybe not this exact model, but I suspect a lot of them have the same I/O PCB. And what's interesting is I guess they have the schematics. I wasn't really expecting the schematics, but I got the schematics for the I/O PCB. That really helped in the end. So one of the plans was to run a cable from outside the unit to a through-hole connector port on the I/O PCB, but that was abandoned. But those are the two pins. There's actually a few pins that are tied together that you could use on that particular connector. So looking at the schematic, it became apparent that the through-hole connector could be used as a convenient way to redirect the power bank port to the charging port lines. All that is required is removing two wires from the connector prior to connecting, as well as connecting two pins of the through-hole connector. So this is some partial disassembly. This shows the I/O PCB at the time it was removed. I was seeing if I had clearance through that old port for the umbilical, which I didn't do. So at this point, I had removed the two wires from that connector, which are actually the power bank output voltage. And those type of connectors, they have tabs that you can put a screwdriver under and then pull out those wires. So this is the upper side of the I/O PCB after I had removed the micro USB connector. The connector had dangerous metal bits in there. It was broken, so I wanted to get rid of it. Originally I tried desoldering it, but I just sort of pried it off in the end, and fortunately it came off rather gracefully. I was concerned about that. So this is the backside of the I/O PCB, showing the connections between 2 points of the through hole connector. And at the time, I didn't think of loudspeaker vibration, so I'm hoping this holds up in the long term. Here I made a glue gun blob around the ends of those wires so they wouldn't touch anything and totally destroy the unit. Yeah, I think I did it again. And what happened there was I just decided that it wasn't going to work to do it the other way. It's going to have too many physical issues. I had to drill holes or something, and I kind of like this solution better because it's kind of the same thing as the original solution, but it's more robust. So we'll see how it goes, but I'm getting the feeling that that's going to be working.
So I designed this huge board. It would accommodate 16 of the superclusters, and each of the superclusters would be routed to a huge expansion board. This design was already huge and barely manageable by KiCad.
Off to Moscow for the show.
Ну, вообще, Абрамс вытащили буквально там 4 дня назад с поля боя. То есть